Okay, so now slightly different type of KSP problem. We just calculated that the KSP for silver phosphate is 2.83 times 10 to the minus 18th. So we know that number. So now our question is, can you make a solution? Is it possible to make a solution that is 4.10 times 10 to the minus 6 molar Ag plus and 6.32 times 10 to the minus 3rd molar 3 minus. So now we have to decide, will this solution, a solution that contains this much silver and this much phosphate, will that solubility product exceed the KSP or will it not exceed the KSP? If it exceeds the KSP value, we can't make the solution without it precipitating. If it does not exceed the KSP, then we can make that solution successfully. So now we're going to calculate a Qsp. It has the same setup as KSP, now it's just Q because we're not sure if it's at equilibrium or not. So Qsp is a concentration of Ag plus that we have cubed times PO4 3 minus. And we plug in now the values that were given. So we're calling silver 4.10 times 10 to the minus 6th molar. That one gets cubed. And 6.32 times 10 to the minus 3rd molar for phosphate. So Qsp, we calculate that number. 4.1 times 10 to the minus 6th, quantity cubed, times 6.32 times 10 to the minus 3rd equals 4.36 times 10 to the minus 19th. Now we compare Qsp to KSP. So Qsp compared to KSP, which one is larger? 2.83 times 10 to the minus 18th is bigger than 4.36 times 10 to the minus 19th. Therefore, Qsp is less than KSP. And that means that we can make this solution. Any solution in water that has these concentrations of silver and phosphate will not precipitate. PPT is what we usually abbreviate precipitation with. So no precipitate forms, we can make the solution. You'll be asked these problems in a variety of different ways. Can I make the solution without it precipitating? Will a solution precipitate at such and such concentrations? You got to be ready for all those combinations and recognize what they really mean. When you're given concentrations and a KSP, typically you have to calculate a Qsp. Okay? Thanks, guys.